Okay, we've got a worked example here. It's a transformation in the complex plane. Um, let's have a look. The transformation t from the z plane, where z equals x plus iy, to the w plane, where w equals u plus iv, is given by this expression: w equals 3iz plus 6 divided by 1 minus z, for z not equal to 1. Show that the circle z, modulus of z equals 2, is mapped for t, is mapped by t onto a circle C, and state the center of C, and show the radius can be expressed in the form of k root 5. Okay, so essentially what's happening here is we've got a shape in the complex plane, and I mean, it talks about the Z plane and the W plane, and we can imagine them as being, a transformation in the complex plane. There, these are both Z and W are both complex planes, so it's just a bit of terminology really that talks about the Z plane and the W plane. Okay, so we're basically doing some kind of shift on this circle, and you probably already know, hopefully, that mod z equals 2 is a circle. It is basically the locus of all the points that are of length 2, and from the origin. Z's kind of unshifted. If we had z minus some complex number, then we would be doing a shift, doing a transformation. But this is basically all the points which are a distance of 2 from 0 plus 0i, if you like. Right, okay. So, right, the way to tackle these things, basically, if we make it explicit in Z, make our transformation explicit in Z. So we're going to change this. We just change the subject of it to give us this. And then if we apply U and V to this, it's going to give us this expression here. Right. Okay. So it's explicit in Z now. So that's kind of standard approach that we're going to take with these things. Now, if we apply the condition that the mod Z is equal to 2, then what we're saying, therefore, is the modulus of this is equal to 2, and that's equivalent to saying this. If we just cross multiply this and the 2, we're going to get that. Right, the modulus of a complex number basically is going to be this squared. This left-hand side is going to be 6 minus u squared. Well, it's going to be, yeah, the square of the modulus is going to be 6 minus u squared, and then minus v squared is going to be that. So that basically is the length, like the modulus of that. And if we do the same thing for the other side, we're going to get the 2 squares, of course, and we're going to get that. So this is what we've got to work with. And essentially, if we just reorganize this, go through a few stages here and simplify it, we're essentially going to end up with this. Now, this is, you'll recognize this as a circle. Since this is in the complex plane, this is going to have a center of minus 2 minus 4i. I've not stated that there, but that's what that means. The radius is 20, the square of the radius is 20, so the radius is 2 root 5. So going back to the question, they want it in the form 2 root 5, k root 5, so k equals 2. So that basically is it. So generally speaking, with these, yeah, if we make it explicit in Z and then we apply this condition. Now, there are some of these problems are dealt with in separate videos where we kind of going to equate either or both of the real and imaginary parts. Just it's a slightly different kind of problem, but we'll can see that separately. Now, incidentally, if our condition was, for instance, not that mod z was 2, but mod of z plus 1 equals 2, this would be a circle centered on the point 1 on the real axis of radius 2. So we'd handle it in the same way. The only thing is we basically want to make it this equation explicit in z plus 1. Well, it's the same as what we've got up here, isn't it? We're just adding one to each side. So then we can expand that side and get to this. And then we're just going to do the same thing as from here on, and get ourselves a slightly different solution. I haven't worked it through, but chances are it's going to be something else like a circle. So that's just to put that thought in your mind. Right, okay, so that's it basically. So hopefully that's been useful. See you next time.